The most common security best practice for AI tools is actually a logic bomb that breaks your software. Engineers attempting to secure GitHub Copilot traffic via man-in-the-middle proxies often assume they are creating a safe, inspectable tunnel. In reality, intercepting this traffic strips the cryptographic handshake required for identity verification and context processing. The result isn't safer data. It is an intelligence loop failure where the LLM receives no valid input to process, rendering the AI useless while giving IT teams false confidence that they have secured the connection. This video explains why standard network security tools are fundamentally incompatible with how modern large language models authenticate and function. When a new developer tries to force Copilot through corporate filtering infrastructure, they often encounter immediate resistance from their own code editors. The most frequent failure point is not latency or speed, it is the authentication handshake itself. GitHub Copilot relies on strict end-to-end transport layer security validation to retrieve device codes during the sign-in initiation process. When a corporate proxy intercepts traffic using self-signed certificates, this handshake fails immediately because the agent cannot verify the server's identity against its internal trust store. Users frequently report specific JSON RPC errors with code 32603 and network timeouts labeled as e-timeout failures. These are not random glitches. They indicate that the secure tunnel required for the AI to understand your context has been severed by the very security mechanism intended to protect it. The engineering oversight here is profound because initial releases of these tools completely ignored standard environment variables like HTTP proxy or HTTP proxy, treating network connectivity as a simple routing issue rather than an AI-specific context requirement. Even with basic proxy support introduced in version 1.129, the tool requires specific allow listing of over 20 distinct domains such as copilot.proxy.githubusercontent.com and apby.githubcopilot.com to function correctly. If these endpoints are blocked or altered by a man-in-the-middle inspection device, the service fails instantly rather than degrading gracefully. This creates a scenario where security teams believe they have visibility into all traffic, but in reality, the critical metadata packets required for inference are being stripped away before the model ever sees them. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. A stark example of this disparity exists between different development environments. While VS Code and JetBrains IDEs like IntelliJ or PyCharm eventually received updates to handle specific allow lists or custom tunneling logic, Visual Studio 22 remains an engineering dead end behind corporate proxies. It lacks native support for NTLM authentication protocols that are common in enterprise networks and relies exclusively on Windows system-level proxy settings that cannot inject the necessary self-signed certificates required by Copilot's API. This means two developers using different editors can experience completely different realities with the same network configuration, proving this is not a transient network glitch, but a fundamental platform limitation rooted in how each IDE handles secure tunneling for AI services. The most dangerous aspect of these configurations is what I call the false security signal. Documentation indicates that if a connection only succeeds when using an insecure flag to ignore certificate errors, the trust chain is broken. This state often masks deeper issues where metadata or packet structures are altered by the proxy, confusing the model's inference engine and degrading performance before causing total failure. When engineers see the connection work only by ignoring these warnings, they are looking at a compromised system rather than a secured one. They gain confidence that their data is safe because traffic flows through a filter, but they have no visibility into whether the AI is actually receiving the context it needs to generate code or understand complex requirements. This leads directly to the cost of misconfiguration for senior engineers and architects managing AI adoption in regulated environments like finance or healthcare. You cannot simply turn on an LLM behind existing security infrastructure. You must redesign the network path to bypass inspection for specific endpoints or accept that the tool will not function at all. Attempting to force Copilot through standard man-in-the-middle proxies wastes developer time troubleshooting connection errors such as 407 proxy auth responses and e-timed out failures rather than writing code. It creates a zombie deployment where security teams believe they are monitoring traffic, but the AI is effectively offline due to broken authentication handshakes that prevent any meaningful interaction with the model. Historical data from the GitHub community discussion threads confirms this pattern of frustration across thousands of users. In one specific thread regarding this issue, 22 comments and 70 replies were generated within a single month as developers struggled to reconcile their security policies with tool functionality. The error logs show failures occurring on October 8, 2022 at 2022 service process, highlighting that these are long-standing architectural constraints rather than new bugs. A user reported an inability to configure proxy settings back in March of 2023, and it was not until June 20th of that year that a GitHub employee confirmed current limitations and outlined future plans for better integration with enterprise networking standards. The engineering judgment required here is clear. Do not attempt to secure Copilot via standard interception proxies if you need the tool to function intelligently. Instead, configure strict allow lists for specific GitHub domains and accept that visibility into this traffic requires a different architectural approach than traditional web filtering. If your organization insists on full inspection of all outbound AI traffic, you must be prepared for the reality that the intelligence loop is broken. The trade-off is binary. Either you have a secure tunnel where the model can verify identity and context, or you have a filtered stream where the data flows, but the meaning is lost to the proxy's interference. Organizations attempting man-in-the-middle inspection gain false confidence in data safety while inadvertently disabling the core intelligence loop of their AI assistants. Intercepting traffic via these proxies breaks the secure handshake required for large language models to verify identity and context, turning a powerful development aid into a non-functional tool that consumes resources without delivering value. Visual Studio 2022. Copilot is currently an engineering dead end behind corporate proxies because it lacks native support for NTLM authentication protocols, unlike VS Code or JetBrains IDEs, which offer more flexibility in handling these complex security requirements. When a connection only succeeds when using the insecure flag to ignore certificate errors, you are looking at a broken trust chain where critical context signals have been stripped by the proxy before they can ever reach the model. The path forward for practitioners is to stop treating AI tools as generic web traffic that can be filtered with standard security appliances. You must treat them as specialized services requiring direct access to specific identity endpoints and API backends. By aligning your network architecture with the actual authentication requirements of these models, you ensure that your development team gets the intelligence they need without compromising on the safety standards required by their organization. This shift in perspective from filtering traffic to enabling secure channels is what separates successful AI adoption from costly deployment failures. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.